Good evening, good evening, good evening, good evening. WeatherBrains episode 924 for the 2nd of October, 2023. This is James. This is the pre-show, the magical time where we do three things. We share boring personal stories, humorous anecdotes, and from time to time, we say very outrageous things. Welcome to October. Glad you're here. Going to get a good show going on here tonight. I love October. This might be my very favorite month of the year. The problem is it can be very dry, which it is, but typically we don't have tornadoes yet. Hurricane season fades, and it's just a good month. The temperatures are just amazingly pleasant, so it's an amazing month. So we have Bill and we have Beth. Welcome.
We've got a quorum.
Yes.
Hi.
Hello, Dr. Hall. Thank you for joining us tonight.
Sure.
And as always, we advise our guests to run before we get started. If you need to hang up, this is your chance right here. And just so you'll know, we're live on YouTube now. We'll be live on local television at 7 Central. And most people listen, about 75%, and that the audio drops tomorrow morning. So we like to warn everybody that we're live, just not that you would say anything that you wouldn't say otherwise, but we just like to disclose that fact. So Bill was on a pub crawl last week.
I nearly, what would the word be? Gate crashed or broke into the show so you could see exactly what's going on these pub crawls you talk about.
I would love to see some live videos of a pub crawl. That's awesome. Now, what city was this you were in?
Alpharetta, Georgia.
A suburb of Atlanta on a pub crawl.
No, actually, we were by the pool. It was a beautiful night working on budgets, me and my business partner. And it would have been
I'd rather
boring drop into the pub
needles
crawl.
in my eyes than do that.
I knew you wouldn't. Probably second right behind that would be watching it on WeatherBrains. It was a very nice hotel, though. Beautiful courtyard, Hamilton, a hotel by Hilton. It's very, very nice. And we enjoyed it. It was beautiful weather, had a beautiful altocumulus sky. The old well-defined buttermilk sky was exactly what it was.
We don't believe you. We know that it was a pub crawl. So we, no doubt it was a pub crawl, which is, I have nothing wrong with that. Everybody needs a mental health break. Get off the grid.
I had an unsweetened iced tea. I'll send you the receipt, James.
There you go. So, Beth, where'd you grow up? I asked nosy questions before we get started. Where'd you grow up?
Grew up in Cincinnati, Ohio.
Ooh,
Yeah.
Bengals fan?
Oh, totally. Absolutely.
So what happened yesterday? They got blown out like 27-3 or something. What is the deal here?
I feel like as soon as they, wrote the check to Burrow, all of a sudden things are falling apart. But I'm in West Lafayette, Indiana now, and unfortunately we don't get to see the games most of the time. So I was just watching it like on an online game cast type idea. And it was depressing because I believe the Bengals scored first, and then that was it.
Yeah. Our son is a very avid Bengals fan, which makes no sense. But I have been to Paul Brown Stadium many times, and we've had great experiences there, and we have a lot of fun. And good friend of mine used to play on the line for the Bengals, a guy named Andre Smith, and he's retired from the NFL now. But no, I love Cincinnati. But that was just a very odd game yesterday. It was not good. I think Burrow is hurt. The guy's only probably 40%, and might be time to rethink the strategy.
Yeah.
So Bill,
like a leg strain or something. But
yeah, there's something going on. So Bill Murray, guess whose program I'm going on? Radio show I'm going on Thursday.
I don't know. Coach Saban again?
The Nick Saban show.
Oh my goodness!
I'm going to take that show right down.
Are you the host of it?
I'm the media guest.
Oh,
okay. Normally he brings in these ESPN guys, but he loves weather. He's a weather dweeb. And
why don't you get him on here?
I think I need to get look, Coach, I've done your show twice. The least you can do is come on my show. So I think after the season,
I'll just faint.
we need to
do the show.
But see, he knows most of these sports guys, they know how to, they're trying to poke the bear, get him mad, get their moment of glory where they got Coach Saban mad. And he knows I'm not going to do that. Now, I got some weird questions for him. I mean, I want to talk about his wife, this Thursday night. Because allegedly she told him he's got to start chewing out those players again.
He did a good job. Got him fired up.
I just want to talk to him about how much control that Miss Terry has in the whole situation there. My wife, she controls what I wear. I mean, like Sunday, I was walking out. I do children's, worship Sunday morning, and I was wearing camouflage cargo shorts. And she says, "You're not going to wear that. You're not wearing that out of the house. No, go back and change." And so I went back and changed, and I will admit that camouflage cargo shorts, it's a bad look for me. So, my wife has some control, a lot of control here, but I want to know more about Coach and the
control.
Yeah. I want to know who's pressing the buttons over here. So,
well,
yeah, I'll take you.
I think you saw it Saturday night.
Yeah. So anyway, I'll drive down to Tuscaloosa for that show Thursday at 7. The nice thing about that show is the security. You've got really good security. They tell you, all right, Mr. Spann, nobody will be within range to touch you unless you give us permission. If you don't want to engage with anybody, you tell us and we'll allow that. I like that. And on the way out, I have to come back and do the 10 o'clock. I've got to get out of there in a hurry. I mean, I do have to get out quick. On the way in, it doesn't matter. But I will say he has top-notch security, very good security. I see Troy's back with us this week, and here comes Rick. I know that.
Troy.
Let's welcome our television viewers. It is now the top of the hour. It's Monday night. The Monday Night Weather Party is live on local television. I know that Neil is out and Jen is out. And typically Kim joins us a couple of minutes late as she's getting her kids settled down.
Have a second Boilermaker.
James A. And I see Rick is here. All right, let's get this sucker started here. Record track 1, record track 2. And here we go in 5, 4, 3, 2, 1. Uh-oh. False start. Here we go in 5, 4, 3, 2, 1. WeatherBrains, episode number 924. This is the weekly show all about weather. This is for the 2nd of October, 2023, getting into the fall season here. Let's just go straight to Troy and see if he's dropped under 110 degrees yet. Troy?
Barely.
Now, hey, I do radio weather down in McAllen, Brownsville.
Yeah.
I'm actually forecasting highs in the 70s down there a week from today.
Yeah.
So you got to have some relief coming here.
Yeah, there's some relief coming. We're going to break the pattern finally, I think. We'll see. Fingers crossed. The problem with me all this week is that I've got only like 1,700 different events that I'm responsible for monitoring. And we've got soccer here in Austin out at Q2 Stadium. Austin FC plays coming up on Wednesday evening. That's about the peak time. If you look for the peak time in precipitation, it begins about that time, thunderstorms. And then we've just got a lot of other things through the end of the week. So it's I'm looking forward to the change. And if we can get 2 to 3 inches of rain, that's what the QPF suggests from the National Weather Service and Weather Prediction Center folks. I can live with that. And the models seem to suggest that. So we'll see, fingers crossed, and looking for highs in the upper 70s, I think, by the weekend. I'm a little leery to go. I don't know, James. A little leery. I think the models may be a little bit too cool, given the fact that we've been so dry and so hot lately. But
something about saying 79 is there's something mental about that there's a mental thing. But yeah, the pattern clearly is breaking. So congratulations.
Yep.
And you should be sending thanks to Rick Smith for initiating the pattern.
I've already
change.
talked to Rick about giving it the toll road express through Norman and Kim and James, for that matter, up in Tulsa. So clear it on through.
We're going to push it as hard as we can. Yeah, we're pretty pumped about that too. I mean, we're looking for highs. I think Saturday high in the 66 to 68, somewhere in there, and lows in the 40s. I mean, we're not going to know how to act, I think. But man, bring it on. I'm ready for it. And there'll be plenty to share, Troy, so it's coming your way too.
So James in Tulsa, you have in the chat something going against my Longhorn friends here. What's that? Was there something going on this weekend?
Just one of those.
Oh, there we go.
Hey, Texas is favored.
SEC violation there.
Yep, Texas is favored in this thing. So, but let the hatred begin.
Well, there was an interesting thing today. Not meaning to get off on WeatherBrains football, but we will for a second. There was a real interesting. Someone put what do they call it? X now, Twitter. I can't keep track of all that stuff.
Twitter is the X name, but X is not the X name or something like that.
But someone put out a very interesting poll today, James, all of my James and all the folks here. They said, if you had your choice, would you want Texas to win Saturday and lose at the end of the season? Or would you want them to lose Saturday or win at the end of the season? And 84% on this poll were saying lose Saturday, win at the end of the season. So I don't know. Interesting.
Now, do they still play the game at the original Cotton Bowl, or moved over?
Yep.
They be in that old stadium.
Yeah,
how
11
many more
a.m.
years? Because I got to
11
get over there.
Saturday morning.
That's a bucket
They've
list
expanded
game.
it and apparently fixed the toilets over the years too. So
Wow. And that's a show title.
Then James, we got, I mean, you've already talked about this, but I've got my friends from Alabama coming westward over to my alma mater at Texas A&M.
That's right.
Coming up Saturday at 2:30. Good weather for, by the way, I think both those ball games, weather looks really good for OU in Texas and for Alabama and Texas A&M.
So I did the weather during the State Fair of Texas for like 2 weeks at the State Fair of Texas when I worked for Channel 4 in Dallas. And I was right under Big Tex. And I meandered over the Cotton Bowl and checked it out. And it was not in good shape in the 80s. And hopefully, if the bathrooms are working, that's a good thing. James ate a lot. That makes me feel better about the whole situation. So what's happening in Tulsa town?
Things are pretty quiet. As Rick said, we'll drop into the 40s this weekend, and I'm looking at the F6 pages. I think we got to go back to May 3rd for our last low in the 40s. So hallelujah, hoodies and shorts. That is my favorite uniform.
Hoodies and shorts. Kim, do you like cooler air? Is this good for you?
Oh, yes, I do. Being from the upper Midwest, fall is definitely one of my favorite seasons here in Oklahoma because we actually do have seasonality. It gets to the point where you forget about the other seasons. You forget that other seasons exist when it's just so hot for so long. Yeah. So fall here is such a blessed reprieve. I love it. And for those who are watching the show, you're seeing my oldest daughter is joining us for the pre-show, the early part of the show, by putting stickers on everything, including me. And now she also wants to send the team. So this could be a really exciting show for people who are watching.
That's going to be good.
Well, one other thing, guys, that we need to, before we leave this week, is the biggest week is next week, and especially here in Texas. We got the eclipse coming up, and a lot of people traveling from around the country coming into Austin, San Antonio, places like that for the middle and latter part of next week. I've got a friend coming in from DC, and so it's going to be real interesting next week. Some of the models, have you had a chance to see what some of the models are doing the middle part next week? They tend to pick up that remnant circulation, I guess, off the Pacific, Rick. I at least saw that in one of the models. It tend to be more of an outlier, but I was thinking how disappointed so many people will be if the clouds cover the sky for the about week and 2 weeks down the road.
When is the date again of this?
Saturday, a week from Saturday. Yeah, week from Saturday.
So, and again, let me just say for those that, and I know we got to bring in our guest here, but if you need some eclipse glasses, I am selling these. Once again, they're on sale. And
how much do you want per pair?
Well, yeah, only $9.99. A free lunch is included, of course, with that. So I'm just saying, if you cannot find those eclipse glasses, that's there you go. So
what are those
enough
called?
of this.
Ritz glasses?
Putting on the Ritz. Putting on the
Have
Ritz.
holes in them. They'll put your retina out,
Yeah.
James. What are you doing?
Oh, no. The peanut butter acts as the filter. See, you got it wrong.
Okay.
So Bill
what if
Murray,
you eat the peanut butter before the eclipse? You get
don't do that. That's in the instruction manual.
Okay.
Bill Murray, bring in our guest before she hangs up on us.
If she hasn't already, she's probably
Don't
safe.
go, Beth. Please don't go.
Yeah, tonight's guest WeatherBrains is the director of the Indiana State Climate Office in the Midwestern Regional Climate Center, as well as the operations manager of the Purdue Mesonet. With over 25 years of climate service experience, she's dedicated her efforts toward identifying opportunities for climate data to be transformed into decision support tools and resources for a variety of sectors across the Midwest, including agriculture, urban flood management, and public health. Her research interests throughout her career have focused on climate applications and operational climate tools for stakeholders and decision support needs. Dr. Beth Hall, welcome to the show.
Hi, thanks for having me on.
Well, that
You
bio
guys
will
seem like a crazy group, though. I don't know.
that will clear out all the silliness right there. We'll get down to business.
Beth,
Okay,
that's only 9
all right.
minutes in. That's only 9 minutes in.
Yeah, check us out at about minute 119. So take just a moment, Beth, and for our listeners who might not be familiar, because we have a tremendous range of folks on the show, explain what climatology is and how it differs from meteorology.
Yeah, it's a common question, and we're still trying to figure out how best to explain it, even to students. So some analogies that I use, we've just been talking about sports, football particularly. And so you can use pretty much any sport that you like. And there's usually career stats or seasonal stats, if you will. I know I'm a huge baseball fan as well. And so you can think about their batting average or, average yards per game. That might be thinking of this in terms of climate. But that doesn't necessarily mean that that's how they're going to perform every time there is a play. They go to shoot a basket, they go, at the plate to try and hit. And so that's more weather. And I know that can confuse people when we have phrases like climate change and global warming, and people are like, well, I don't know what this global warming is because it's super cold outside. And I keep trying to say, well, the at bat doesn't necessarily always guarantee that they're going to have the same thing as their seasonal averages. So that's a common aspect of climate science, but so many different subfields of climatology. You could have paleoclimatology, which people are going to be looking at things that aren't your observational data. So they could be looking at ice cores, sediment core. Some of my favorite, because it's just so obscure, are pack rat middens, and that's spelled with a D as in dog, not a T as in turkey. I never know the terms there. And so pack rats stay in the same area for thousands of years, obviously not the same rat, but they're generational thing. And so you can core through that and see what they've eaten and expelled, and that tells you the vegetation and so forth. I would say I'm more in the field of climate services, which is not a very popular. It's a very small group. Essentially, state climatologists would fall into that category of climate services. And as you mentioned, Bill, I'm also the director of the Midwestern Regional Climate Center. So that focuses on climate services. So very simply stated, climate services takes all the observational data that we can possibly collect. And this is hopefully going to be a lead in to other questions you're going to ask. But we try and take all the observational data out there and then transform that into information that perhaps a non-climate scientist is interested in using. So this could be an engineer that needs to replace a bridge, and maybe the specs and the materials they used in the past are not going to hold up to perhaps the extreme heat or the the thaw and freeze cycles might be more common. And so they're going to want to look back and be, well, do we have a higher number of freeze thaw days? Should we be rethinking the materials that we're using as they're replacing storm drainage? They might want to know, well, what is the size that we should be using with heavy rain? So it can go from anything of tourism, agriculture, engineering, water supply. But on my side of the story, it's, well, how can we take that data and give them the information they need? Because a lot of times they don't want the huge data set of numbers. They just want it simplified down to the decision that they're trying to make.
So we're always fascinated at our guests' journeys into their careers. Talk about that for us for a minute. For you, share your journey. What inspired you to choose this field, and some of your key influences in that area?
Yeah, no. And people usually don't decide when they're in high school, I want to do climate services. And in fact, when I was an undergraduate, I didn't even start off majoring in meteorology. I was majoring in telecommunications and just picked up on a intro to weather and climate course. And I thought it was the greatest thing in the world and was doing well at it. And when I graduated, I wanted to be a forecaster actually for the National Weather Service, but they had a hiring freeze at the time. And so the general rule is, if you can't get a job, stay in school and get paid. So that took me out to Reno, Nevada, at the Desert Research Institute, where I then started my master's program. But the challenge there was trying to find a professor, try to find a thesis, what am I going to do for this master's degree? And as I'm hearing you all talk about Oklahoma and so forth, I mean, my ultimate dream was to study tornadoes or severe weather of some sort. And I don't know if you guys realize this, but there's really no severe weather in Reno. I mean, you have snowstorms, but there's no hurricanes. At least I never saw any while I was there. And though I guess this year they had remnants of one come up. So that tells you how crazy our weather's getting. But the thing that is somewhat exciting there are wildfires. And there was a junior professor at the Desert Research at the time that was working with the National Weather Service, and the National Weather Service always sends out fire technicians on the big fires so they can monitor the weather. And they said, but we have no idea what normally happens. And that ties into the climate science. I mean, they can monitor the radar, they can launch the weather balloons, they can see what's really happening, but they didn't have that climate perspective to know, so is this typical or not? So that started the funding actually for my master's degree, because the idea is they wanted to know, what is the climatology around the whole Western US? And really agencies, federal government agencies, Forest Service, Bureau of Land Management, they really were excited about this because they need to position their resources, whether it's the planes, the slurry, that pink stuff that they drop on it, the people, the firefighters, the trucks. And it costs obviously a lot of money to guess wrong. So they're very interested in knowing, based on what has been happening, where are the highest probabilities of a natural ignition occurring? And of course, we need to look at historical data to better understand that. So that's really how I got into the field of climate services, was this need to better link the data that we have, say, going back even 100 years and wildfire ignitions with the decision making. Where are we going to put our resources? Where are we at most risk of a lightning ignition? So maybe a week ahead of time, we can start repositioning a lot of that fighting crew.
Hey, Beth, one thing you mentioned, and it brings back memories for me many years ago, and this is way back. I think Roger Lamoni was actually the WCM there in Reno, but I remember sitting at the WFO on the hill out at the Desert Research Institute one day, and we had some thunderstorms in the area, Beth, and where we actually watched the lightning actually ignite. You could sit up there on the hill and watch this happen. And I just remember how interesting that was, and being able to see this. And again, this has been way too many years ago that happened, but it's pretty amazing out there to watch that.
It's absolutely beautiful, and you feel kind of guilty watching
Yeah.
it. But in one of the big add-ons at the Desert Research Institute, I want to say maybe in the late 90s, they built a very tall tower. The initial point of the tower was to do drop studies of different ice crystals and hydrometeors, we call them, raindrops or whatever. But it was a beautiful watchtower at the top. So anytime we knew storms were coming in, a bunch of us would go to the top, and we might bring some drinks of choice and just sort of watch the 360 view. And because it's so dry out there, virga was the common thing. So rain that falls and evaporates before it hits the ground, but there's still lightning. So even though the atmosphere is generating the molecules enough to build the charge, the ice and the water and so forth, the charge can be developed, but it's not hitting the ground. And so that's what's going to ignite it. And so you can almost see the lightning strike and wait a few seconds. And do you see a little plume of smoke?
Yep.
Maybe it's just a fun, enjoyable game, and you just hope no one ever gets hurt, of course. There's a lot going on in the chat, and so I don't know if I should keep this or not.
We try not to distract you.
You,
with the chat,
you don't want to watch the chat, Beth.
Yeah, don't even look at that.
But James, they had an anecdote
here that I'm missing, or what's going
No,
on.
no. You
No.
just pretend it's not there.
That's always the best strategy with that. As quiet as Reno weather is from a severe weather standpoint, and Rick had looked up the data there, but I had remembered that was one of the first radomes in the 88D network to get torn up by wind. And of course, Rick had the stats right there.
Yeah, it looks like
Well, it's interesting you brought that up, because when I showed up as that fresh young master's degree student, this would have been in the early 1990s. They were just installing that Doppler radar system up on Virginia Peak, except because you can't put one of these things down in the valley where all the people live, and in complex terrain it has to go up on the mountain, which was okay. But because of the virga I was just describing, they said, well, we're never going to get the most accurate amount of rainfall down in the valley. So they turned to me and said, hey, the Weather Service is funding, a study, if you want to do it, to try and mess with the algorithms with the new Doppler station. And so then you'll have the data, and yet we'll have rain gauges down in the valley, and you can do the study. And I was like, okay. I mean, I was just thrilled to have a project. The interesting thing, though, is it was so new. It seemed like no one knew how to pull the data out. And I thought that was kind of funny. It's like they were sort of okay, we're supposed to be collecting this data, but does anybody know how to pull the data, and in what format, and how do we get it to her? And there was also quickly the reality of, don't I need a couple of years worth of data to build these algorithms? And that wasn't my plan, even though I ended up staying in Reno for 12 years, because I became a associate research scientist. Once I graduated, I got my PhD there, and I loved Reno. I mean, the climate is wonderful, how it would get really hot during the day and then cool at night, and just everything about it, particularly weather-wise, was a wonderful location. However, as a forecaster, I would joke saying you get 360 days of clear and sunny. So if you really are somebody who gets into severe weather, Reno may not be the place to be. But that location up on the hill just is so scenic. And then thinking about how I was there in the early stages of the Doppler, and they were like, we don't know how to get the data.
That is so funny. Isn't it fun when you get advisors who are all excited about you diving into a new data set, and then have no idea how to actually help you to do that? Not that I've ever been in that position with students, but I have absolutely done that. And sometimes you just hope that the student will put in the legwork to figure out how to do it. If it turns out that you can do this, then you'll do groundbreaking things because no one else can access this. It's great.
Exactly.
So I am so interested in the work you did out at the disaster research.
Where her brain is.
Disaster on the brain.
Norman, Oklahoma.
So many acronyms. There's a disaster research center, and I have to keep that separate in my mind from the Desert Research Institute. So DRI is an organization that our listeners may not be enormously familiar with. And I was wondering if you could just tell us a little bit more about what this organization does and, like why Reno, Nevada? Like that just seems like such an interesting place to try to do things that are weather and climate related. Now there is a very, very important set of reasons, a lot of it having to do with things like water. I'd love to just hear your take on that as an institution, what it's there for.
Yeah. Oh, wow. And, I moved away from DRI, I think in 2007. So I'll be making up a lot of facts from here on. No, I'm just kidding. It celebrated, gosh, it's got to be getting close to 90 years now. Or maybe even more than that. I've lost track, but they've been around for a very long time. And yes, the main focus initially was water resources in the desert. And so there was more of a hydrological focus to their research. And don't forget that not only are we talking about rainfall, but snow. Snowfall is incredibly important throughout the Intermountain West, and the Sierra Nevada is right there. And so it was looking at so much of the hydrologic cycle and groundwater, stream flow. There are rivers that are going through the West. So what is the story? Can it sustain the population and so forth? But I think they quickly realized we almost need meteorologists there too. So they then had this division of hydrologic research, but then division of atmospheric research. And that was the division that I was in. And I think they also had like a division of quaternary sciences, which is more that paleo, not super paleo, but they're looking beyond the observational period. So that's where I learned about these pack rack middens and ice core research and pollen sediment cores and tree rings and so forth. So it was fascinating research that they do there. And they are part of the University of Nevada System of Higher Education. Their main campus is in Reno, but they do have a campus, or did at the time, down in Las Vegas. And they actually have a satellite office up in, I think, Steamboat Springs, Colorado, because again, looking at the snowpack, snowfall, how can we better understand it? Does the type of snow make a difference, not just in terms of snow water equivalent, but is there anything we can glean? There's a lot of cloud seeding studies that have been done there where they're testing, does it work? Does it not work? How do we try and increase the amount of precipitation? So in a sense, it's a major research arm of the University of Nevada system. So realistically, I lived and worked and did everything at the Desert Research Institute, and then would just go down to the campus for the classes when I was doing the degree work. But yeah, it's a wonderful institute, and I'm thankful that you're allowing me to give time to promote it, because I think more of the public should be aware of that. They might have heard of the Scripps Institution of Oceanography or Woods Hole, but really the Desert Research Institute competes with those very nicely.
Yeah. It's a very fine institution. And that actually leads into a second question that I have. I heard you say you left in 2007. And knowing that you love severe storms as you do, I know there's so many divisions of DRI that do so many things. But did you ever get to do any of the stuff that the like field campaigns to observe severe storms that DRI participated in? I'm just curious. There was one I got to do called IHOP, which was actually kind of advanced storm running awaying. It was billed as storm chasing by my professors at Purdue, who were geoscience professors who wanted students to just like take their GPS equipment out to the field and see what happened when it would sense through moisture discontinuities, which was part of the IHOP like campaign. But we were just like tagging along with this experiment. It was really, it was interesting. But there was a whole team from DRI there too, who we kind of actually followed for a time. And I was just curious if your interests ever got to blend in doing that, or was your life just totally separate? Like the DRI stuff, you didn't get to touch the severe weather piece very, very much at all.
I really didn't get to study that part. In fact, when people would ask me, oh, what do you do, around Reno, the joke was, well, I guess technically on the resume, it says I'm an atmospheric scientist, but what I do is computer programming, all day, day in, day out, whether it's crunching the data or developing a new tool for the internet. And at the time, I feel like the only field projects that were really promoted was the ones in Colorado to study winter storms and so forth. But I've always been, I love snow. I get so excited about snow days, but I don't like being out in it. And that field experiment was really more for people who love to ski or snowboard. And I just knew I was going to break a leg or something, and it was not going to be worth it. In fact, out of the 12 years that I lived in Reno, I never went skiing or snowboarding. I mean, all the Tahoe ski resorts are up there. And I was just like, nope, I value my legs, my knees, my ankles way too much.
Yeah. Being from northern Indiana, which I can that's going to bleed over into my next question in a second, but I can absolutely identify with that. Is I have no idea how to ski. The closest thing we had were these like little bunny hills that were artificial hills made in like southern Michigan. It's like that's right. Where I tried skiing once and almost died and decided never.
And Beth, that's the way I am. I actually out at Incline there in Reno. Went out there one time, and I'm the adult standing there with fifth graders going about 70 miles an hour around me. And that was about the last time. I figured I needed these limbs to be intact, Right.
So, exactly. Yeah. Not on my bucket list in any way.
Well, there's some broadcasters who apparently don't share that wisdom. I didn't realize that Henry Rothenberg, our friend in Nashville, had gotten seriously hurt by ended up on a black diamond a couple of years ago by accident when he was trying to catch up with some other meteorologists. So best advice is what Beth is pushing here. Stay away.
I agree.
I look like a helicopter
ski
crash.
Resorts are going to be happy hearing this, though, right?
This is not an endorsement, apparently, for any ski resort.
No.
Anti-commercial tonight. But I was interested to come back then to your more recent stuff. Let's go to the Midwest. Let's go to Indiana, and I would just love to hear a little bit more about the work that you're currently doing to try to bring all of those climate insights. You defined climatologist so beautifully. So what are some of the things that you're working on in the Midwest where, it doesn't get a lot of attention when it comes to things like climate and climate change and all those conversations? A lot of it happens surrounding coastal communities. Last week when New York got flooded, there was this whole political contention about, well, is this just New York's life now because climate change and so on. So tell us a little bit more about climate in the Midwest.
Well, I believe in climate change. And even say believe in is sort of that awkward thing of this isn't a religion. I mean, it's real, but I just can't jump on the bandwagon of soapboxing. I'll leave that. I feel like there's plenty of other people out there that are willing to stand up and really make big statements about it. So I do get invited quite a bit to give talks about climate change in Indiana, and I will certainly do them, but I tend to emphasize more from the historical climate perspective, because I feel like that's more grounded in reality. And I hope that my audience appreciates that too. This is the trends that we're seeing. And you can see that trend doesn't seem like it's going away. So if you are thinking about the next 5, 10, 15, 20 years, just extend that line. And so in that sense, we can maybe bring it more to home, because you're right. People in Indiana, people in the Midwest, when they think climate change, they think of that picture of the polar bear on the last ice cap, and immediately they're like, this doesn't relate to me. And interestingly, when we look at global temperature departures, I'm always amazed at how the Midwest seems to be under this cool donut hole, which has also been difficult because everywhere around us in the world, it seems like it's been warmer than normal. The planet has been warmer than normal. But in the Midwest, it seems like it's been remarkably staying near normal. Now, obviously, we do have our exceptions, but that makes it even harder to sell to the everyday person. But I think something I do talk about is we can't think about this in terms of a year or a decade. Sometimes we need to go shorter time frames. Seasonally, like maybe if we did add up how much our total annual rainfall was, the difference from yet one year to the next is not maybe that big of a deal to the typical person. But if we start saying, but now it's all falling in, say, 20 rainfall events as opposed to 40, that means it's heavier rainfall and so forth. So I try to bring in time scales, temporal scales, and thinking if the temperature in the month averaged out to be normal, we can look back and think, yeah, but 2 of those weeks were horribly hot and heat indexes in the triple digits and so forth. And then the other 2 weeks in the month, it was so unusually cool. And we need to break it down smaller, because what we're seeing is that pendulum is swinging from one extreme to the next. So when we do average it, which is what climate scientists tend to do, it's like, yeah, the average makes it look normal, but we're on this roller coaster ride we have not been used to riding.
You talked a little earlier about looking at these climatological records for design things, infrastructure stuff. How do you factor in climate change into that when you look back at this record of normals that might not necessarily be reflective of what's to come?
Oh, good question. And I don't know if I've really had a job purpose to do that. I think it's important, but I also am very driven by soft funding. So what that means is somebody has money and they're going to willing to give it to us to do a project. And very rarely does the project that the sponsor is funding want to look at that detail. So I haven't had the opportunity or the amount of free time to dive into that sort of question of how is climate change affecting it. What we tend to do, particularly for the Midwestern Regional Climate Center, is again, build these decision support tools. So one example is that is just being released, I think this week, is a soil temperature climatology. Growers, farmers really determine when they apply chemicals, when they can plant, when they can do nutrients, when, and this is going to sound weird, but again, it will tie into perhaps later conversation, the 4-inch soil temperature is sustained at or above 50 degrees Fahrenheit or at or below 50 degrees Fahrenheit. They know this, but who's measuring soil temperature? So that's a problem. It's like they know these rules, but where is the data coming from for that? Well, now that we have more and more state Mesonets that are being installed, and we can talk about that more later, I'm sure. But now that we have more of those, the question is, so what is normal? Again, coming back to that, what is the baseball player's career stats? What is the typical date when the 4-inch soil temperature hits this? And then I start to think, and is that date different if you're talking clay soils, sandy soils, loamy soils? Yeah. Does it matter, if we're thinking row crop or if this has really been fields dedicated towards orchards and so forth? So it just tends to open this can of worms that I think are very realistic, very tangible, which was another thing that drew me to this field. I think I was always scientifically inclined, but when you think of the traditional sciences, chemistry, biology, physics, we're almost getting to the point where it's so micro scale or so abstract. How can we even wrap our brains around it? But meteorology, oh my gosh, we can apply all of this to our everyday life. And there's so many answers yet to discover.
I love that. And in that, you mentioned something that is really worth following up on. In Indiana, there are all those different soil conditions, all those different soil types. It strikes me that Indiana is a really climatologically very interesting place. And you might be able to, classify it in a lot of different ways. There's a lot of different experiences one can have living in that state. Could you talk a little bit about that, serving as the state climatologist for a place that is so widely, just so variable with so much going on? And, what does that look like from north to south and east to west? What all do you encounter in your work?
Oh, you're putting me on the spot, assuming I'm a geologist, but I am trying to learn these things. For example, the northern part of the state, I believe, has sandier soils. how that relates to me is the farmers were going to need to irrigate more. Historically, we think of Indiana and Illinois, Ohio, we call those rain-fed states. You can fairly dependably assume you're going to get rain throughout the growing season so that you shouldn't have to irrigate like you start seeing in the Kansas, Nebraska, Front Range states. If you're flying over those states, you see all those circles, you know, of the fields where they're irrigating. But when you fly over Indiana and where I'm at, you don't see those circles so much from the plane. You actually see squares because it's a rain-fed state. However, because the soils are so sandy up north, and there are some sandy soils down in the southwestern part of the state, I believe, then irrigation is needed more. Also, yeah, I mean, just the soils themselves dry out. You really can't assume it's going to be the same story. Where you move further down, south, central part of the state, you're going to hopefully have more of that loamy soils that can retain the moisture better. And then the rolling hills start. I don't know how many of the listeners and viewers are familiar with Indiana, but I think many think of it as flat as Kansas. There's nothing, you know, no topography there, but really that's only the case from about Indianapolis northward. Once you get into southern Indiana, it's this beautiful rolling hills that you might be envisioning more in Kentucky or Cincinnati, southern Ohio. So with those rolling hills, and all of that came from the glacial advance back from our last ice age, or several of them, you get this rolling hill topography with different soils. It can be very rocky as well. And so if you're thinking about just the heat retention of rocks within the soils, that's going to have an impact as well.
Yeah. Oh, all the topography is so wildly variable. And what does the lake do to the climatology of Indiana? I imagine that it has a really interesting and maybe complicated set of moderating forces, if anything. But there's also a question that I've seen about, you know, the delay in getting the lake to ice over in the winter. Perhaps is something that's happening, and you know, just there could be some shifts going on there. So tell us about the lake and what it does.
Yeah, so Lake Michigan of the Great Lakes is the one that touches a teeny tiny part of Indiana, and it can have a great effect on lake effect snow, depending upon the storm track passing over Lake Michigan. I think Michigan benefits, the state of Michigan benefits the most from lake effect snow, but you can have that dip down into the far northern counties of Indiana, which is fun if you're into snow or you're wanting to watch Notre Dame football of some sort and really enjoy what the impacts could be there. But you're right, with the increased delay of the freezing of the lakes, that is having an effect, one of which is it's able to evaporate perhaps many more months out of the year. And that evaporation is not only adding vapor to the atmosphere, not necessarily in terms of lake effect snow, but it's now decreasing the water levels. And the water levels are very important to the full economy around the Great Lakes, and not just on the US side, but the Canadian side. And there's great partnerships between US and Canada about monitoring the lakes and so forth. But if it doesn't freeze over, it can impact the storm tracks going over the area, but it's also going to allow more evaporation. You guys are having a lot of fun in the chat. I just can't read and keep up at the same time.
Show title.
I was apologizing for all the Indiana love. I'm so sorry, everybody. Go at other people who aren't from Indiana. Please ask questions.
I'm glad in a way, Kim, that you're doing that, because I'll take the Indiana love rather than James from Tulsa with all of his stuff that he manages. So take that any day. Hey, Beth, I've got a question for you, and this is totally driving to the other edge of the cliff for a second. I have always been very much impressed with what we do at our regional climate centers. You up there and John Nielsen Gammon, of course, down here in Texas and all around the country and out at Reno. I've got a question for you, and this has been something that's concerned me, and sometimes I worry that I'm sitting here by myself sometimes with this. But you know, with the advent of Asos back in the mid-90s and going to that system, we left manual observations at airports. About that same time, we also cut back on it. I know it was done at the very end. It was you'd probably scientifically didn't want to look at how the sausage was made, but we kept track of sunshine minutes.
Mm-hmm.
And with Asos, we kind of dumped the baby off with the bathwater. And since then, I just haven't been that impressed. I know we have satellite cloud product percentages prepared by NOAA that we get via goes east, goes west. But I'll tell you now that talking to someone that we all know in the last couple of days, I had a question for NCEI about whether that satellite cloud product is even being used, and it's not. They're not ingesting that in any of the LCDs or any of the products there. So that's not being done. Does that ever worry you that, we've got weather observation stations in Mexico to our south and Canada to our north, where they still cloud type in the weather observations. And we just dropped that. We dropped that when we went to Asos. And I've always wondered about cloud climatology in this country and what we ended up throwing away when we went to Asos. There are a lot of good things that we got. We got a heck of a lot more weather stations now that we can keep track of. But I've always wondered about that cloud climatology, Beth. Does that ever keep you awake at night like it does me?
I don't know if it keeps me awake at night, but I might say I have shower moments of panic where, I'm trying to get ready and I'm like, oh my, how are we going to deal with this? I mean, we're just losing so much data.
Yeah.
And certainly in terms of the cloud cover data and climatology and just being in the field that I am with climate services, data is so critical and essential. And we can even go back to the basics with the Weather Services Cooperative Network. So volunteers and how we had, so many thousands and thousands of volunteers back in Civil War time. We had the medical officers at the different forts that were doing handwritten records because they were the ones, believe it or not, that were either literate, right, or we could read their handwriting, which is funny today because the joke was always, you can't read the doctor's handwriting.
Yeah.
So we have all of that historical data, and unfortunately, that network is fading. Our volunteers traditionally were farmers, producers, and as that mom and pop farm is being sold off to the major companies, you are then losing the observers. But you're right, there were several parameters, I think, with that were being done at airports. In fact, when I was doing my undergraduate in Indiana, at Indiana University, as a matter of fact, I did a week-long shadowing, or maybe it was a 2-week shadow at the Weather Service in Indianapolis, and they were located more at the airport as opposed to their current thing. And so I got to spend a day or two actually hanging out with the observer who would go out and assess, is this 100% clear skies? Is it 50% clear skies? What do the different cloud decks look like? And we've lost that. And we will get requests, I would say 3 to 5 times a year, at least at the at our Midwestern Regional Climate Center, but even as a state climatologist, because growers always want to know, was this summer sunnier than in the past? And there's always that anecdotal part of, I just felt like it was sunnier this year. And is there any way that you can back that up with data? And it's that awkward, not really answer. We just don't have it, which again is one of the values of these Mesonet stations, because where the federal networks are scaling back, and on one hand, I understand that. I mean, it's my tax dollars that are funding a lot of this. And so we were saving money by not funding people to make those more manual observations, but at what price? And from the climatological perspective, because I think even I'm in the Department of Agronomy at Purdue University. So I'm surrounded by a lot of agronomists, people who study crop production, field production, and they're always wanting to know, how do we explain the yields this year compared to last year? And sometimes that sunshine, I don't know, photosynthesis might have a role in it. And we just don't have clear-cut answers for that.
Yeah.
So I don't know if it keeps me up at night, but every time I see maps or if somebody does reach out to us and say, hey, can you tell us if this has been a sunnier summer? And I look and see, well, what what data is available? To my knowledge, in Indiana, there's one station that is operated with the federal network through one of their climate reference network sites, and it's down in South Central Indiana that might have that data.
Right.
And that's solar radiation, and that's not even cloud cover. So that might just tell us how many watts per square meter we're getting. And is that going to be different than perhaps the fraction of the sky that's covered with clouds? And what kind of clouds? I mean, we know that high cirrus clouds have a totally different radiative impact than low cirrus or stratus clouds. And until you have someone observing stuff like that, we're missing a lot of story that can be useful.
Well, you know, I was going to
looking at alternative energy sources.
Right. And with solar power and even things like that we see nowadays. But, you know, I was going to also, like you mentioned, give credit to the Mesonets, because we're seeing a lot of solar information being made available through them. I'm hoping, pushing, and maybe got a little good news the last week or so, that with the SLEP program in Asos, that in most cases, as I understand it, our Asoses, we could open the salometers up to 25 or 30,000 feet. Most of the Asoses, at least it's a single laser beam up, which is negative. It's not like, you know, the good old days. But at the same time, I'm hoping in the future, trying to beg Washington into opening up these salometers all the way, because something is better than nothing sometimes, especially at unaugmented aviation stations, the smaller airports and places like that. Thank you for your response.
Hey, Beth, I'm really interested in learning more about the Mesonets. Being here in Oklahoma, of course, we've got the fabulous Oklahoma Mesonet right down the hall. And I also want to, before we get into that, really mention that Jay Farlow, who's a really good friend of the show, giving us lots of great guest suggestions. He went to a program, I guess, about setting up Mesonets, and he suggested we have you on. So let's thank Jay for that, because you've had a lot of very, very interesting information. So thank you, Jay. I guess just talk a little bit about your Mesonet. I mean, how did it get established? How many stations do you have? Just kind of the basics.
Does the audience know what a Mesonet is first before I launch into that?
Let's assume they don't.
Okay, because I get a lot of questions, and as I'm trying to build the Mesonet in Indiana, several colleagues have said, have you thought about maybe using a different word? Because nobody knows what the word Mesonet means. And so how are you going to get people on board with supporting this, either financially or emotionally, if it's a term that no one's familiar with? And my comeback is, but that's the term. And maybe my onus is to really use it as often as I can so that people are no longer asking what it is. So in my definition, and there are multiple definitions out there, I would say that a Mesonet is a network. And in fact, it is just a combination of two words, mesoscale and network. But it is a network of high quality, research grade weather stations. And I throw those in, and I don't know if research grade and high quality are being redundant, but I feel that the more we try and emphasize that this is good stuff, this isn't just people deploying a lot of weather stations out there, and there's plenty of people doing that, and it drives me crazy, that it is filling a niche, if you will. So I often say, people are like, well, what does mesoscale mean? And in meteorology, mesoscale has a certain geographical scale. I mean, synoptic scale can be a third of the US if you think, these big fronts passing through, and microscale could be the fog settling in that valley, and mesoscale could almost be anything in between. But we did have a national Mesonet meeting in Davenport, Iowa this last July, and somebody pointed out, stop thinking of the word mesoscale from the meteorological standpoint. Think of the term mesoscale in terms of a synonym for middle. And I really liked that, because we have, in a sense, three categories of weather data out there. We have those that are operated by the federal government. And we already talked about those, the cooperative networks, the ASOS, AWAS networks, the climate reference networks. And so we have to assume, and federal aviation and so forth, that these are high quality, maintained, our tax dollars fund. On the complete opposite side, we have what I would call personal weather stations. And there's a lot of weather enthusiasts out there. I'm sure that makes up a lot of your audience, who just have always loved weather. And maybe for Christmas, somebody got them a cool little weather station. Maybe it came from any dealer, retailer out there, and they have that hooked up, and that connects to the World Wide Web. And so everybody can now see the data, and that's wonderful. The problem with that, though, is we have no idea if they mounted that weather station underneath the roof eave or over the grill or, on the edge of the deck type thing. Also, I love those weather stations. I wish I had one myself, but instruments fail in time. And anytime there's a moving piece of equipment and the wind, we call those anemometers, when they spin, anything that has bearings is going to deteriorate and really should be replaced annually. Same with a lot of the precip gauges that come with those. They're tipping devices, so they have to work on a fulcrum, a little hinge, if you will. They're going to rust. It's water, people. And so oftentimes I'll ask them, oh, and when did you swap out some of these sensors, or when you calibrated the sensors? Because these aren't the most expensive things. A Mesonet is in the middle of those two, where they almost all are being managed. In fact, I can't even think of a Mesonet that's not being managed out of a university, and usually a research one university. So not only are they having to stay very well maintained because they're going to be used for research, right? Where the home weather station, that personal weather station, that's being used for fun. But a research one needs to be high quality. Perhaps one would argue even better quality than our federal networks. I mean, those just need to make sure the planes don't crash, right, when they're coming in for landing. But research quality needs to be something different. That usually has to employ people, technicians that are going out and visiting those. So when I was director of the Midwestern Regional Climate Center, when it was at the University of Illinois in Urbana-Champaign, I did not manage a Mesonet, but I worked with all of the state climatologists around our 9-state region. And I would guess about 6 of our 9 states had a Mesonet. And we're very proud of it, but they all were struggling because who's funding these things? Who's supporting it? They're great when you have research grants, but research grants tend to end. And then what do you do with the weather station? Now do you have to let go the technician that's been making sure those sensors were very well calibrated multiple times a year? And so I realized in talking to the different state Mesonet programs, maybe we all need to come together and have a therapy session and just maybe exchange notes to learn what we're doing. So I started to have an annual meeting, bringing together these people. But what's interesting is I never could figure out who was in charge of the Mesonet that was operated out of Purdue University. See, I'm trying to get there. I'm trying to bring this story around to the initial question. And it always baffled me. I'd reach out to the state climatologist saying, who runs your Mesonet so that we can bring them to this meeting? And I wouldn't get a clear response. So then in 2019, when I left my position in Illinois and moved to Purdue, within the first couple days, I kept asking people, who's in charge of the Mesonet? Because for like the last 6 years, I've been trying to get them to the table. And awkwardly, this one gentleman said, we're kind of hoping that you would take it over. I have no field experience. Like I said, I was a computer programmer more than anything else. So it was that pause, that awkward, that I'm trying to remember if my job description even mentioned this, which it didn't, by the way. But I was excited because I also knew that the Purdue Mesonet had so much potential. It had started back in the late 1990s, which is fairly common because that's when the technology became affordable. We had the World Wide Web that was developing, internet, so that all of a sudden multiple universities were like, well, maybe I can get some money to put in a station. Purdue University manages 9 agricultural research centers around the state. So the idea is we just want this for research. And because we're so agronomy focused, we'll just buy and install these weather stations on these 9 separate farms, which they did. But when I showed up, I was like, why are we stopping there? There's so much of this state that is not getting covered. And there are variables of the atmosphere that are not getting observed. Let's take this to the next level. And the National Mesonet program was maybe 5 years in at the time. And that's a program that NOAA funds because they realized the Weather Service needs good data. Sure, they were pulling in data from Weather Underground, from these personal weather stations, but they also were like, oh my gosh, we have all of this high quality data. Can you imagine how that could benefit the different models that are being run for forecasting? So I knew that if I wanted to take advantage of some of that funding, and the National Mesonet program, everyone knows that's not going to fund a whole network, but it helps. I needed to start installing soil moisture sensors. I needed to do more soil temperature sensors at different depths. The issue of low level inversions was becoming a concern in the ag community because of the volatility of several chemicals that are applied to plants, that once that chemical volatilizes and starts drifting, it can actually take out an entire crop. And they know that it's more likely to destroy crops when a low level inversion is in place. But ironically, nobody knows anything about low level inversions because no one's been monitoring low level inversions. And I'm talking boom height of the field equipment. So maybe 3 meters, 5 meters. What's going on within that 3 meters? Do we have an inversion? So since 2019, I've been working to add these additional sensors, but also expand the network. So we're now up to 13 stations. I have 2 more in my office that's been taking forever to find site hosts, because obviously now I'm trying to find people that are not Purdue University landowners. But I've started to work this year with state governments. So Department of Natural Resources is interested in this because of all the state land, natural parks, state parks that they have. They also have the water division there. You also have Homeland Security. So every county in theory has an emergency manager. Imagine how useful that would be to have high quality weather stations in every county, which I know is, Oklahoma's striving for that. Kentucky is getting close to that. New York has gotten really close out of extratropical storm Sandy. It was Hurricane Sandy before it got up to New York. So they were able to install it. But if every county has that high quality station, now we can look at rainfall rates. We can look at risk for flooding. We can look at winds, how bad are the winds? And when FEMA is providing disaster assistance, they need proof, right, that the weather was that extreme. But if the closest high quality weather station is 4 or 5 counties away from where the disaster happened, that makes it extraordinarily challenging for agencies such as FEMA or even just private insurance, homeowners insurance. We'll get asked a lot at the Midwestern Regional Climate Center, hey, I have this insurance claim. Can you verify if the winds were indeed that bad to destroy their roof? And we're like, well, the nearest station is like 3 counties away. So I think that's a big push for why these Mesonets are so valuable. The challenge, though, is, and we are working to improve this, but every research program, every university, every state in theory can build a Mesonet however they want. And so you worry about cross-state, interstate consistency of these. Are we mounting all of our sensors at the same height? Are we burying them at the same depth? Are we using the same sensor technology? For example, is one state Mesonet using tipping buckets for their rain gauges, but another one's using Wade precip gauges? And do we need to worry about not necessarily apples and oranges, but maybe Macintoshes versus Fiji or something? Can we build more regional scale data information products if we're mixing and mashing Mesonets of different standards? Excuse me. So the American Association of State Climatologists, for about the last 5 or 6 years, has been working to try and bring all of these Mesonets together so that we can at least exchange notes. Maybe even get questions like, hey, what are you using? We had a lot of wildfire smoke come into the Midwest through a lot of the country this year. So we've been getting more and more questions of, hey, are you measuring wildfire smoke? Are you measuring particulate matter at your Mesonet stations? Well, very few, if any of us are. We have the National Atmospheric Deposition Program that does that, but again, the density of stations isn't very high. But maybe we should be monitoring air quality more and more. So now we send off on our listservs, hey, does anybody know of an air quality sensor that's worth putting on our sites? Is, what are the pros and cons of this sensor versus that sensor? So I'm pleased to say that communication is improving among the Mesonet community across the US. But, as long as there's no consistent federal one source of funding, we all are scrambling for dollars, and we're going to kind of have to do what the sponsors want us to do.
Yeah, it's interesting you talked about, people don't think about, you got to go find a spot to put this weather station. You've got the equipment, but I mean, here in Oklahoma and West Texas, we think, well, gosh, there's spots everywhere. There's lots of open spaces, but you can't just go stick it in a field somewhere. So I thought that's very interesting. We work very closely with the West Texas Mesonet because our office covers 8 counties in Texas, and they've been slowly building that network over more into western North Texas in our area, and just watching them, the process of them going through trying to find a place for the station is just really amazing. You talked about some of the technology and measuring air quality and things like that. I know one of the things that we would kill for on the Oklahoma Mesonet is webcams, cameras on the stations. I know that introduces all kinds of challenges. Is that something either that your Mesonet or you've heard other Mesonets talking about adding that technology?
Yeah, and I think more and more Mesonets definitely want to do it. Now, the initial thought is Big Brother's watching, and are you just talking? But I think we're seeing a lot more research applications with this, because you can compare what that field looked like 2 years ago from that camera versus this year. Or even if you look at the 2012 drought versus, say, the flash drought of this year, how is that impacting the environment? Weather Service can use it to, and I love this idea, to identify precipitation type. The radar may not always tell you if it's snow, if it's freezing rain or something, but the cameras can help guide us on what type of freeze or precipitation. The challenge with cameras, though, because I'd like to do it at our sites, and I feel like I have 2 main challenges that I'm facing. One is, what kind of camera? So do I want a stationary camera that's always pointed in the same direction? And you can see value in that, because if it doesn't move around, well, now you have this fixed picture that you can compare. But you're limited in the field of view with that. So some Mesonets are doing more the pan, tilt, zoom type of camera, where they can control it. Maybe they even give some control to the Weather Service if they're trying to see a storm coming in or something like that. There's phenological cameras that perhaps can pick up spectrums that look at more plant health, which might be of bigger interest to vegetation and to better understanding what are the impacts of a drought situation that's coming through. There's some that actually have a camera facing one direction and a camera facing the other direction. They're stationary, but now you almost are getting 360 degrees. So to me, all of a sudden my head was exploding. I'm like, I don't know. And of course, there's a cost to this, and I don't want to make an investment and then realize, oh, I should have done the pan, tilt, zoom. The other challenge with cameras is, obviously you can imagine the amount of data that it is collecting. So if it's going to be a live stream, think about the data size that is coming through the system. So a lot of Mesonets don't do the live stream. They might do a picture every 5 minutes or a picture every 30 minutes. Almost all Mesonets are going to be powered by solar energy. So in the wintertime, you're going to have to slow down the number of pictures, because our number of sunlight hours is decreased, particularly in the northern latitudes. So and just one snapshot can put a big burden on the power supply of these. The other thing I realized is I had a wonderful setup of this cute little solar panel and a little battery and the data logger. But once you add a camera, well, now it's not just the cost of the camera. I'm going to have to double, if not triple, the size of solar panels. I'm going to have to really double, if not triple, the size of the batteries. The data plans, a lot of Mesonets transmit the data through cellular technology. And of course, they're going to be happy to charge by the amount of data being transferred. Well, if you're initially just transferring numbers of what was the temperature or how much rain fell, that's very small versus now a gridded image that is going to be a lot larger in size than really single numbers that are coming from each sensor. So that power demand, the data cost for communication, and then what type of camera, it just makes me panic. So, I've been trying to reach out to the different Mesonets to find out, what are you guys using and why, and is it working? And the other problem is because it's so new, they might have only had the cameras in place for say 3 years. Well, if we're going to make a huge investment, I kind of want that to last a lot longer. So am I an early adopter to trying this out and just crossing my fingers that I won't be throwing money down the hole? Or do I wait a little bit longer to see which cameras really hold through?
So Beth, in Alabama, we really could use a Mesonet. So if you were giving advice to an organization of, how to get started and sort of what the, per sensor cost might be roughly, what would you say to that?
So not thinking about cameras or air quality sensors, just your basic Mesonet for us runs about $12,000. And then you got to think about, the site hosts, and you need to put a fence around this for security. There's concrete costs. And I know within the last year, just supply costs have gone up for some of this material. So I would assume more $12,000 to $14,000 to just get started. It's never just the station. A lot of people think that a Mesonet is the cost of the station, and then you get cool things on your phone afterwards. So it's typically not that difficult, knock on wood. I mean, it's still hard to approach people who are willing to write a check so that you can buy some stations. But the challenge is, keep in mind, you're also going to need to hire an IT person that understands how to pull in the data, organize it into, say, an SQL database, how they need to be able to write code to quality control the data. We need to make sure is this good data coming in or not. And this could be probably at least a half-time position, and IT people aren't cheap. You also want someone, a student could be a good start, but you need that consistency. So students are wonderful for short-term projects, but you don't want them to come and go and then have no idea what's going on with the data. You're going to need technicians, people who really understand the instrumentation. For us, we ask that our technicians visit every site at least 3 times a year. Once a season, we give them the winter off because it's kind of pointless at that stage, at least in Indiana. So who's going to be doing that? We've been lucky really getting kind of a pseudo-retired person who's willing to work hourly. But we see the job announcements and it's a small field. So where are you going to find the technician, the IT person, the manager, which I would say might be more of my role? How do we track? So who's setting up the forms to track which sensor is at what location? Setting up the communications plan. Are you going to go through your university, and that can be a nightmare in and of itself, or do you want to take care of it a different way? So the more thing that we want to promote with Mesonets is, yes, it's a network of weather stations, but it's really an entire infrastructure, an infrastructure of data collection that needs to also be operational. So while you always say thank you to the person that perhaps wrote you a check to buy a station, where are you going to come up with the money to keep that station at the high quality longevity that we want? Because again, you can have research projects that fund it, but when that project ends, what is your plan to keep that station collecting data high quality enough that you can now start using it for climate studies?
So do you have to go to the landowners, and do you have to actually change the surveys and get long-term rights to use the site, or is it just simpler than that?
So we built off of Kentucky. Kentucky is a very well-regarded Mesonet, much like Oklahoma, and they're our neighbor to the south. So, and I had a close relationship with that whole crew. They always had an agreement in place with the landowner. It was like 3 different contracts that were essentially signed between the landowner and the university. One might be the installation agreement of this is what's involved. One might be the ongoing maintenance agreement. Like, we really hope you're going to maintain the weeds. between visits and so forth, and just the general what's involved there. But I did learn at this national meeting that many Mesonets don't do that at all. They just have a verbal agreement with the site host to install it, which on one hand, I was like, well, that might have made life a lot easier for me, because my problem is I have cheerleaders. I can find people that love the Mesonet, they love the idea, and they want a station on their school property or in their backyard, or, you name it. And so we get so far along, we put in maybe 5-6 months of building this relationship. And then when it's time for somebody to sign the contracts, that cheerleader is not the one with signature authority. So now I'm like, well, who's going to sign the contract? And they're like, and then they know who it should be, but that person's like, yeah, no, we're not doing this. We're not doing this at all. And I just sit here going, oh my gosh, we just lost all of that time. So I'm learning as well that I need to figure out who has signature authority pretty soon in the conversations before we invest that much time. Because I think it is useful to have that contract in place. I think it's risky. It's a risk that I don't want to incur by just assuming we have a verbal agreement.
Right. I could see going as far as getting easements and things eventually that protected you in the long term. So if you had to spitball the long-term annual maintenance costs, I know there's obviously a lot of variables there, but how much are we talking about roughly to maintain one over an annual basis?
Yeah, I'm still trying to collect the data myself and the cost, mostly because we have so many sites on Purdue farms and that messes up the data. But in talking to other state Mesonets, the estimate that they typically quote is around $3,000 per station per year. But to me, with 13 sites, I would sit there going, yeah, no, it's a lot more than that. But for larger networks like Oklahoma or Michigan or Kentucky or New York, they might be like, yeah, no, I think that's a pretty good ballpark number. But, if you think about who all I was mentioning, the other number that I heard is you want one technician per about 15 stations. So you can't just have one technician thinking of that cost, that you need to scale this larger. Now, maybe you just need one IT person, one programmer, regardless of how big the network gets, but you are going to need more technicians the more sites you get. And that's money, that's salary, that's benefits. I also heard that you want to have a 10% overage in all sensors, so that if a sensor dies, you can go right there, in your cabinet and pull out a replacement and do it. So how much is the cost of keeping a 10% inventory around as your Mesonet grows? So I'm okay with the number 3,000. I would think, if you're just starting off, you might need a little extra help up front. And honestly, the National Mesonet Program funds around that amount. I mean, depending upon what your network is, it might be around 2,000. And to me, I'm like, even that's not enough. So I just think perhaps with inflation and the cost of people and so forth, probably a safer number would be $5,000 or $6,000 per station per year. But I also hesitate there. But it's like, well, but once you get over 100 stations, I mean, isn't there a bulk rate you can think about?
Yeah, you're trying to scale it up. You're trying to get the economies of scale. So who are some of the stakeholders, Beth, that you recommend that organizations talk to in terms of, helping to pay for the Mesonet and also using the data?
So ideally, if you can get money from your state government, that would be great. But we're kind of in a chicken and egg situation in Indiana, where you want the state to fund us, and at the same time, the state doesn't know about us because we're kind of small. So how do you get them to fund a small program? And you can't grow unless you get them to fund it. But I have heard that there might be some specialty groups out there, particularly in the ag world, maybe some engineering groups, or maybe there can be just some grant opportunities that can help start the Mesonet and get it growing. And then you almost got to hook them in. You've got to also develop the apps. You've got to develop the tools. So all of a sudden they become dependent upon it. And I've heard of cases of other Mesonets, I won't say the name, but when funding was starting to die down, they were just slowly turning off data feeds. And all of a sudden people are like, where did this go? We totally needed it. And I'm like, if you want it turned back on, we need money to support it. But this is where, on one hand, it's great to have that independence, flexibility, research, university world of managing a mesonet on your own. At the same time, you kind of think, shouldn't we be getting support elsewhere? Because this is almost a common good. The value that comes from mesonets is a common asset, a societal asset that really should be supported through tax dollars, either federal or state or local. And it shouldn't be about scrounging for dollars, because it's a safety issue as well as a research issue.
Yeah, just to kind of like the local affiliates do when the charter communications or somebody cuts off the SEC football, then you turn over to that channel and it's gone, and you tend to see these things getting resolved pretty quickly. Troy, you had a question for Beth.
Yeah, Beth, one thing that my colleagues north of the Red River up in Oklahoma really did so well, and I can see so many amazing possibilities, but the outreach, I mean, this information for K through 12 and for STEM programs and things like this, getting kids involved and creating the interest. Is that something that y'all have done at Purdue? I assume that's got to be an important part of it.
Mm-hmm.
We just don't have the capacity. We don't have the people.
Okay.
We don't have the funds to do it. But something that did work is just the interest of schools to have it. So in far southern Indiana, Crawford County, now it's not on the river. The county's on the river, but it's on the north end of the county. There was a school, Crawford County Schools, that were very interested in this and saw the educational benefit of having it on the school property. And so we try to advocate for that and go down and visit and do training with the students. And this is how you can look at it, because it's more than just learning about the weather. You can imagine all the disciplines that can come into this by just looking at data. How do you visualize data? How do you write about data? I mean, you can bring in English about it and communication. And so there's so many educational opportunities. And when it's in the student's backyard, it tends to make it more real for them. But until I can expand my staff, and again, it's always that tough of how do I expand my staff without having more stations and so on and so forth.
Well, it seems like to some degree, and I think there was that success in Oklahoma, Rick, to be able to do that, and maybe not even Beth having a station at the school, but just getting the school kids where they were looking at that data and being able to visualize it and know this is what's going on now, and this is what we can tell. In a way, I got to think that helps publicize your effort as well, and getting the Mesonet message out there.
Mm-hmm. Mm-hmm. I agree.
Yeah, I tell you, it seems like the Gary McManus's daily email that he sends out is one of my favorite emails to read every day, just because he cracks me up. I know James A is going to be standing by to take that position when he retires.
Those are big shoes to fill.
They are. I tell you what, that is a fascinating read every day, and it is very, very educational. You talked about inversions for a moment, Beth, and I really am kind of surprised at how little there is out there about them, because we were approached by a company that needed information in terms of sound transmission. And so, what you said there really resonated with me, and educate me here, being a little ignorant. Does a typical profiler give us temperatures up through the atmosphere so that we could verify model data? Because, the forecasts are coming straight off a model. How good are they in terms of determining the depth, the strength of the inversion, and how fast it dissipates?
So profiler in terms of like a ground functioning instrument, or like weather balloons?
No, you only can get so many balloons a day.
Right.
Something that's permanently there, obviously a tower probably doesn't go high enough. You need to be able to go, it appears to me, about 2,500, 3,000 feet to know what's going on with that inversion. So is there anything that we can use at the ground to tell that, and how much does that cost?
Well, it's the application of what inversion are we talking about? Because if it is a weather balloon, by the time you let go and it takes its first sample, it's going to be pretty high up, and in terms of agriculture, far beyond the height of where the boom is. And even the ground profilers, I believe the New York Mesonet or the New York Micronet has several of these. They can pick up some inversions, which is helpful, but again, it's much higher than what we're trying to do for the agricultural thing. I mean, we really are looking at about 3 to 5 meters, and the ground one might be able to do it. And I had looked at maybe we should get some of those profiler instruments for our Mesonet, but they are super, super expensive. I want to say like in the tens of thousands of dollars, if not even beyond that. And then what I was hearing and talking to my colleagues is, and when one goes bad, the cost to get it repaired is just astronomical too. And then shipping costs and all of that. So right now the cost is just too prohibitive. But for the application that the agricultural community is looking at, we needed to know about when there's an inversion within the first 3 to 4 meters. And there really is no way to do that with weather balloons or even probably those profilers. But how you can do it is just add more temperature sensors to the towers of a measurement station.
Yeah, and James A says drones. That's a good idea. It sounds like a great application for a field experiment somewhere. Now you mentioned computer programming, and obviously that was a passion for you. For some young people it is, some it's not. But AI is changing the field there. Talk about the changes that are coming in relation to that.
Yeah, well, when I was a programmer, I did Fortran 77. So my staff today just laughs because they're like, who uses that? I'm like, I think there are still people that use Fortran 77. But you're right, with AI and machine learning, I think there's a lot of opportunity to do even more advanced quality control tests. There can be more advanced, perhaps, interpolation beyond just Kriging methods and just averaging, within it. I think that we can use that to even assess more risk, because if we have the historical data, then the machine learning, we've done a project that uses machine learning to assess the risk of a flash drought developing over the next 2 weeks. And so I think there's a lot of opportunity for both of those to maybe help, not so much the forecast side of it, but the risk probabilities that is more climatology based.
Yeah, my 16-year-old finally got into a programming class and he's excited, but I wanted to know what language he was, using. Was he using Python or, were they still, he's just like, it's all object oriented.
Yes.
It's just programming blocks. And, the most valuable thing to me about all the computer classes I took in the 80s was the study of algorithms and understanding how to build data structures and how to organize things. And I still think that has value to know all that. We're going into a flash drought here in Alabama. Talk about the increasing frequency of those and how that's a big threat going forward.
I haven't seen data in terms of it's more frequent than not, but that would be my gut feeling. But also we are now studying flash droughts. And even that term is relatively young. I mean, droughts we have been aware of, but trying to apply that rapid intensification. And some people in the field of flash droughts tend to get very passionate about not using that phrase, that they would rather have people say rapid intensification of drought, because you can have it occur in a lingering drought situation. It's maybe kind of hovering in the abnormally dry, but then all of a sudden it just intensifies within a week or so. And so how is that different than the flash drought? I think from what I had said earlier in the show, we're seeing the pendulum swinging on one side or the other. And so to me, my hypothesis would be that we are seeing a higher frequency in this rapid intensification or flash droughts, because we're going from one storm period of heavy rain, and then all of a sudden it stops. And you have then this feedback with the temperatures, and it's just coming on suddenly, where perhaps historically maybe you had some light rain showers in between, but it's like it's either a downpour or it's nothing. And that's going to create more of a flash drought or rapid intensification of drought environment than perhaps our more historical, slow moving, it's creeping up on us and we just aren't getting a lot of rain, but we're getting some rain. And so when is the true start and end of it?
So let me ask a question. In fact, let me share the screen here. And for those that are listening, this is the Climate Prediction Center 8 to 14 day U.S. hazards outlook. And they are highlighting a bizarre shape over the Southeast United States for rapid onset drought. And so my question, but first off, is there a difference between a flash drought and a rapid onset drought, or are they two terms for the same thing? And number two, how is this map derived?
I was worried you're going to ask that last question.
Yes.
So,
yes.
So the National Integrated Drought Information System, and that was a lot of words, so that's why we just say NIDIS. NIDIS is an interagency program, interagency predominantly federal, that is focused on drought, and they are very interested in funding a variety of research projects. I believe they contributed a lot of funding to this product that you're showing that they're now using operationally. I think it's every day it's updated, but they also funded the project that I was just describing, where we looked at the artificial intelligence, machine learning to figure out onset. So I think all of our groups are trying to look at different ways to define it. One of our biggest challenges, and I think all of the research groups that are trying to look at flash drought, rapid intensification, is how are we defining, first of all? I mean, I think we spent a whole year just trying to figure out, because we needed historical cases to build the model off of. And we're like, what is the definition of it? And some people would say, well, if soil moisture drops below a certain percentile, great, that makes a lot of sense. But like we said, that not a lot of people are measuring soil moisture. So I don't have a historical picture of this that's continuous across the US. I might have the Oklahoma network that I could get it from, but I needed a full US picture. Other people might say, well, why don't we use the US Drought Monitor? And if the US Drought Monitor deteriorates 2 categories over a 2-week period, and keep in mind this product is released weekly, so that's a coarse temporal resolution in and of itself, then that's what determines the onset of it. So you would ask, what is the difference between flash drought, rapid intensification, and onset? Part of it has to do with these different things of onset. When will it start? When will it develop? So this particular product that's being released is trying to provide guidance of where there's a high probability of flash drought developing, the onset occurring. And our project was doing the same too, trying to give a probabilistic risk of where and when flash drought will occur. What was mind-boggling though for our tool that we were testing is people would look at this tool throughout the year, throughout the season, and it would be very dry. We all knew we were in a flash drought, but the product wasn't indicating that. And they're like, well, your product's not working. But we would come back saying, no, the product is just predicting when it's going to start, not that we're currently in it. And so it was kind of but see, we feel like we're in it. We need to see a map that says that we're in it. So I'm guessing that this particular product that you're showing on the screen they use some sort of definition, and there's a lot of them out there, which makes this field difficult to study at the moment. And then they went back historically and figured, okay, what were the conditions that occurred when that happened? And are we seeing those conditions when we look forward in time with our forecasts or our climate outlooks?
And again, I think it's a situation where we have to communicate this. And if you were to go into the Dollar General store where real people live, real people, Walmarts, and they're in Scottsboro, Alabama, and they see there's no threat of a rapid onset drought risk, but 50 miles north, south, east, and west there is, and there needs to be a way to communicate this to the people that we serve. And I'm afraid sometimes in the science, we've gotten away from understanding that. And I understand everything you're saying, but that is a bizarre looking map for those that are not watching, they're listening. You go to the Climate Prediction Center site, cpc.ncep.noaa.gov, and you'll see that. And again, I guess my request from those of us that are practitioners, it's maybe just a little more information like you've been sharing. This has been great tonight. It's been a great learning experience, but we need to be able to communicate this map because now this is smeared all over Facebook and X and the social platforms and television. And it's a newer product. And yet people find themselves in that position where, well, I'm not in the risk of a rapid onset drought, but 30 miles north, south, east, and west of here they are. What's the deal? And I can't see any difference in soil moisture, any difference in rain we've had for the past 6 weeks, 6 months. What's the deal here? And I guess it goes back to communication. We have to be better at communication. So one more quick question. We got to take a break. We're actually late. UHI in long-term climate records down here, a lot of the stations that were established 100 years ago, these things were literally in cow pastures, and now they're in a steel and concrete jungle. How do you accommodate for that in climate records?
Oh, yes. And that comes up a lot with climate deniers, in a sense, climate change deniers, because they're like, oh, we've just urbanized everything so much. When we do look at historical records, typically we will ignore those sites. We do know, we have metadata that, yes, this was in the middle of a open rural environment, and now it's, too close to the city. And of course, it's going to make things look warmer. So I don't think we would ever turn off those stations, but we do try and keep record of urban heat island effect, and that maybe this one should not be used for the global temperature patterns and understanding it. I always point out to people that, we still are looking at a lot of data from ship tracks that don't have cities building up around it. And we are putting a lot of credence in those stations that have maintained their consistent environment, say over the past 150 years. So not every station had a city grow up around it. And a lot of times I feel like I'm hearing that from people more in the eastern part of the US than the western part, where it is sparse out there in the West. You can drive for hours and hours, if not a day, before you hit the next city. So there's data out there that we can capture. But I think that the climate scientists do keep track of those that had a changing environment that could impact the historical record. And we aren't putting that in. We're not trying. I'm sure some people might, but I think the general scientific community tries to respect the fact that, of course, that's going to deteriorate the story, and we don't want to lose the trust in the public by using that data.
And let me chase one rabbit, and we got to take a break. What is this New York flood? And this is for everybody here. Have you been seeing all these headlines? No warning, no warning, no warning. It happened without warning. Wasn't there a flash flood watch issued a day or two in advance, and the flash flood warnings were very timely? Why are they saying this? What kind of a narrative is this? Does anybody know?
I think it's a narrative of how there are apparently high school people working in media outlets nowadays that take this. I don't believe any meteorologist or climatologist would say that the Weather Service didn't do a great job. Private sector probably did a great job with that event. But I think you have people that are in newsrooms nowadays that it's amazing.
And I think some of the politicians are saying this. No warning, no warning, no warning. No, it's some kind of narrative, and I just don't understand that. And,
where are people getting their news? We are assuming that everyone's watching the 6 o'clock news, that they're looking at the newspaper and seeing stuff, that they have the National Weather Service app on their phone. I mean, these are people that are perhaps not focused on the same news sources that we are. There's whole generations that perhaps have not looked at a true weather forecast in a while. So I think you said it earlier, we need to improve communication. We need to figure out what they're looking at. But quite frankly, we need to also focus on education in this country, because I think the education, when we say there's a 60% chance of rain, are we educating our youth well enough to even understand what a probability means?
No.
So when we show those maps, like the risk of a rapid intensification for drought, to them it's binary. It's drought's going to occur, and that's weird. So I look just on the other side of that line. Well, if we could improve education so folks would understand, one, what is risk when you think of even insurance risk versus probabilistic risk? And I know these are big words. These are difficult concepts, and they are very conceptual, but I think we need to work on this better.
Well, and the problem is that, in my opinion, James, you can tell me, but I mean, there's just, and I think Beth points it out very well, is people are depending upon clickbait to know their news, and boy, that's a sad state of affairs for us.
Well, a great example is so Wednesday we have a national EAS test, and most everybody here knows that it's going to be at like 1:22 Central.
Yep.
And WEA is going to sound, and it's at the little test, which they've done before. Well, you got TikTokers, millions of views. They say, well, this is going to activate the chip that was put in you when you were vaxxed, and your mind will be controlled for a split second by Bill Gates or, the government or something. And people believe this. People, millions and millions of views. And they're going to turn their phones off all day Wednesday because they don't want the chip in their body activated, and they're going to be controlled by the government. This is the world we live in.
Well,
they are not capable of thinking for themselves. And Troy, you've said this.
But
what happened to critical thinking? What happened?
That's what critical thought involves hearing both sides somehow. We didn't see this over the weekend. Critical thought involves hearing both sides and somehow finding middle ground and having some agreement. I don't think we've seen any agreement in Washington in the last 35 years. No offense, but that's the way it is. And I just think we've got to get back to critical thought. And personally, I think our universities and our education system has failed us to some degree. I think COVID has diverted us, and I believe that we need to get back to critical thought. I believe critical thought is the number one reason that students go to universities. Majors are the second reason. Critical thought, and that has escaped us now.
And we become zombies following these political extremists, right-wing and left-wing political extremists, and we're incapable of thinking. Maybe these people are not really people we should be following here on either side of it. But anyway, I'm chasing a bad rabbit. We must take a break. We're going to do Tony Rice and the astronomy report. We're going to hear from Jen. Jen could not make it live, but she did send a This Week in Tornado History. We're not going to have an email report this week, but we're going to come back and we'll do picks of the week and much more as WeatherBrains rolls along.
Looking beyond the atmosphere, here's Tony Rice with your astronomy outlook.
We're just about 2 weeks away from the annular solar eclipse on Saturday, October 14th. This will be visible to everyone from northernmost provinces of Canada all the way down into Argentina, and from Alaska out to the Western Sahara. But the best show is going to be along a 1,900-mile-long path, stretching from the Oregon coastline to Corpus Christi, Texas. Across Oregon and Nevada, the period of annularity observers will see the ring of fire, about 12% or so of sun not covered by the moon as it moves across the center of the sun. That'll last about 4.5 minutes. Central Utah gains a few percent in another 10 or so seconds. Albuquerque, New Mexico will see 4 minutes and 45 seconds, and that continues to increase through Texas to just over 5 minutes as the shadow moves out into the Gulf of Mexico. This all maxes out off the coast of Nicaragua at 5 minutes and 17 seconds. The width of that path varies a bit from 138 miles in Oregon to 116 miles at the point of greatest eclipse down in the Caribbean Sea. But the shape of the shadow varies even more. It's at its roundest in Central America, just a little shorter than it is wide. But near the beginning of that path, it's 6 times longer than it is wide. It's also moving a lot faster, north of 30,000 miles an hour as the shadow first touches the western limb of the Earth in the Pacific Ocean about 800 miles south of Anchorage. And it's going about 5,700 miles an hour as it reaches the Oregon coast. Just under 4,000 miles an hour in central Utah, a little more than 2,500 miles an hour in Albuquerque, and about 1,800 miles an hour as it makes its way out of Texas. By the time it reaches greatest eclipse off the coast of Nicaragua, it's traveling about 1,250 miles an hour. Then it speeds up again as it crosses Central America into the Atlantic Ocean. Why the deceleration as it moves eastward? And why does the shape of the shadow change so much from extremely elongated to nearly circular and then back again? This happens because the Earth isn't flat. Think of a basketball with a light shining on it. I'll steadily pass a tennis ball between that light and the basketball. Is the shadow tennis ball shaped? Well, maybe in the middle of that path, but at the edges or limbs where the basketball is curving away. It's much more elongated and moving much faster. The more popular question about the eclipse is when to look. This is a very localized experience. So the best answer is to go to tinyurl.com/October23eclipse or OCT23 eclipse. Click on your city and then click on the little clock icon on the right to change to your local time zone. All the times you need for the start and stop of the show are there, along with other information, including the speed of the shadow and the obscuration or percent of the sun that will be covered by the moon. That's your astronomy outlook. Follow me at RTP Hokie for more spacey stuff like this.
This week in tornado history, an outbreak of 11 tornadoes hit parts of Arizona on October 6, 2010. This was the largest number of tornadoes to strike the state in a single day since records began in 1950. This was also the largest single-day tornado outbreak west of the Continental Divide. Per the NCDC, on average, Arizona receives 4 tornadoes annually. 2 of the tornadoes during this outbreak were given an EF3 rating. Tornado number 4, also known as Belmont West, was the second tornado to impact this community during the outbreak. It is one of the strongest tornadoes in Arizona history and has the longest tornado path recorded in the state at just over 30 miles. Severe tree destruction was found in the forest south of town. Complete blowdown of the forest occurred and trees were even stripped of their bark. As the tornado passed through Belmont, it derailed 28 train cars. The other EF3 was tornado number 9. It had a 4-mile path and developed 20 miles southeast of Tuba City. Despite being in an unpopulated area, it managed to become one of the most intense tornadoes in Arizona state history. 3 500-kilovolt electrical transmission towers were collapsed. One of these large metal towers was ripped from its anchoring and completely flattened to the ground. For the National Weather Service Flagstaff, the winds may have been as high as 165 miles per hour. Check out our in-depth and up-to-date summary of this event at tornadotalk.com.
Thank you, Jen. And since Jen is not able to join us live this week, we'll hold the email segment, do a double email segment next week. And we've already done a weather roundup. I guess the only thing we've not talked about is the tropics. We're doing the show on October the 2nd. We have one tropical storm, Philippe, which is near the northern Leeward Islands in the Atlantic. That'll be moving north, should be passing east of Bermuda in about 4 or 5 days as a hurricane, then headed out to the North Atlantic, and really nothing threatening the contiguous United States, at least for the next 5 to 7 days. But a reminder, hurricane season runs through the end of November, so we're not done yet. And Troy, the Gulf waters, that Western Gulf, really have not been touched this year.
Yeah, very, very warm and a lot of latent heat caught up in that. So we'll watch it, but I don't know. It seems like I'm wondering if the upper level winds more disruptive over the Atlantic now because the El Nino is becoming a little better established, but we'll see.
Yeah, El Nino's been doing its thing, and hopefully that will prevent something from happening. Sometimes these little backyard systems can sneak up on you late in the season, especially when the water's not been touched, like that's been the case for much of the Gulf. We had the Big Bend, what was that, Ophelia or
Idalia.
the one? Idalia. That's the one that came through up toward below Tallahassee and Cedar Key, but the western half of the Gulf is pretty untouched, so we'll see.
And one other thing too, James, is that Western Gulf, I don't believe, and correct me if I'm wrong, someone, but I'm thinking that Western Gulf is not as much influenced by the El Nino effects. I'm not sure. I've read several things about that not as much as perhaps the more areas out over the basin.
Right. The MDR is more impacted than that Western Gulf. So we'll see. Never take your eye off the ball.
True.
But I do think we'll be in pretty good shape weather-wise for the Cotton Bowl game. Red River Shootout. What do you call that thing?
We call it the Red River Rivalry again, which is the hardest
rivalry
thing ever in the world. Yeah.
All right. And in Alabama's game at Texas A&M looks pretty good. So it's not 110 degrees, which is good. But anyway, let's morph on here to picks of the week. This is where we're going to go around the horn here, and everybody's going to share something that's weather related that's kind of cool that people might enjoy that are listening to us. This can be a website, a social media post. It can be some hardware, anything remotely related to weather. And I picked some of the video coming out of Utah today. I don't know if you guys saw the snow video today. I like watching snow video, and it was good. I mean, some of the images and video coming out of Utah, just good old heavy wet snow here on the 2nd of October. Just great stuff. And let's go to James Adelot. I think you got a social media post too of something cool.
Yes, it was big flows of hail in Las Vegas, New Mexico. That's east of Santa Fe on I-25. They even had the snowplows out, removing it off the interstate. A lot of video of that. Really, really cool. And a good place for it, away from my roof and away from Kim's roof.
And I will say the first time I saw one of those posts, I'm thinking Las Vegas, and I looked at Nevada like everybody else would do, and of course there's nothing going on there. Oh, New Mexico, and I remember from my Dallas days there is a Las Vegas, New Mexico, and yeah, that video is just remarkable. Quite the show there in advance of that trough. All right, so let's go over to Rick Smith, who's got an amazing pick. I bet. Rick, go.
Yeah, back on, I guess, a week and a half ago, Saturday the 23rd, there was incredible supercells at sunset and during the early evening that were 1,295 pictures of on social media. This is one of the best ones. Alex Spawn caught this storm down in southeast Oklahoma. It's just incredible structure, and it doesn't look real at all, but it's definitely real. I know Kim had some great pictures, and I posted one. But yeah, this was Alex did an amazing job with this picture.
Yeah, that's stunning, and I will agree. It almost looks like an AI kind of thing, but goodness gracious, what an image! And again, all the links will be posted for those listening on the website weatherbrains.com in the show notes. All right, Kim, give us something good.
Yeah, I'm going to bring us back to the conversation we were having about the New York flood. My pick of the week has a general documentation of what went on. And in it, there's this really interesting little quip that's just like a throwaway, well, climate change is making stuff like this happen more. And I think that's a really interesting thing to think about in the context of this particular event. It may be that there's contributing factors that are part of it, but something that's really unique about this event, and I think is one of the reasons it flew under the radar, is the rainfall wasn't associated with any large system of any kind. There wasn't a story to tell. It wasn't part of a tropical system. It wasn't part of a large frontal passage of note. It was the kind of thing that actually happens at this very stationary, weakly forced, which also makes it a little bit tougher to nail down in models until you get really close to the event situation. Like, it was one of those kinds of events that are difficult to identify. And once you have identified them, difficult to really talk about in a way that is attention catching. So I think that part of this is going to be that we need to take stock of how we as a community draw attention to and describe flooding events. This is a kind of flooding that has occurred in the northeastern US time and time again to horrible effect. And I think about some communities in Maryland that have had this happen multiple times in recent years, where they'll just get this deluge of flooding when one of these little boundaries just sort of sets up over an area, and you just end up getting the brunt of it. But it's not something that's very easy to forecast. So I think WPC had stuff that was going out. They were really hammering the message starting when the models were revealing, like the cams were all unified. When the cams became available at that time scale, they were all unified and putting down a bunch of rain over the New York City Metro or something close to it. It was very localized. But did our product suite have the capacity to really describe like a pinpoint, like lots of rain in one specific spatial location? I mean, and call it something like a potentially catastrophic situation, something to really raise alarm bells. I don't think that that's really what the product suite is designed to do. And they did up it to a moderate risk, but let's think about this. Do we do the same things for WPC's products that we do for SPC's products? Are there the alarm bells going off when they've got a moderate risk? And are we looking at the details of what that could mean? And yeah, James put in the chat, the flooding is generally so mesoscale. And that was the case here. There were embedded mesoscale features that really drove a lot of the rainfall rates being so extraordinary. And so there was just a lot to the story. And I feel like there are a lot of people who are pointing fingers when really what we should be thinking about is this is a difficult scientific challenge that is also a very difficult communication challenge for very logical reasons. And yeah, if we're going to be thinking about a world with climate change where that moisture availability is probably going to be part of the picture in the future, if you have these boundaries that set up that are fed by an extraordinary amount of precipitable water, which was the case here, then yeah, we might expect to have this more. We should probably start thinking about the way that we communicate rainfall threat. And that's my pick.
In concerning the event, it didn't affect every borough in New York, did it? This was just part of the city.
Yeah, I don't think it got to Upper Manhattan. It was very extremely localized to like Brooklyn and Lower Manhattan, especially Brooklyn. Like that, I think was the place where they had some of the worst. And it was you look at some of the imagery from this, and it was so pinpoint. And it's extraordinary that it starts down at this intersection point between, you know, where like Long Island meets mainland, and you know, then it fans up into the rest of New York and the northeastern states. It was really interesting. From like, I don't know that I've ever seen anything quite like that. So yeah.
And it's not sexy because there's no hurricane with a name. There's no, you're right. It's a no-name system, and no-name systems don't get that much attention. And so I agree. There's work to be done here, but that's a great pick. And thank you, Kim. Troy, let's get a pick from you. Go.
This is the second time that I've done this as a pick. I was kind of deflated, if you will, back when we got the word back in September that the Aviation Weather Center webpage that had been delayed. Okie James, I know you're aware of it because of the aviation stuff. Well, at 3:30 this afternoon Central Time, the brand new service change notice came out that we're now looking at Monday, the 16th of October. I have passed on the beta site. Be advised, I have problems if you use Firefox. I've had problems with Firefox, but Google Chrome works very well with the beta program, the Aviation Weather Center. I really think they've done an amazing job with the new site. Want to take a look at what they're still putting the finishing touches on, you can do it at my pick of the week.
Very good. Okay, Beth, we have stalled long enough. So we're going to turn it to you, and I know you got something really good.
I might have to deviate a little bit from, I think, what people are talking about of what happened this week, but I will so take this opportunity to promote one of the products we have through the Midwestern Regional Climate Center. This time of year, I think of when is the great ginkgo drop. And in fact, we have office pools going. And I don't know if you're familiar with this, but the ginkgo tree, if you're in an area with the ginkgo tree around, this is one of those trees that as soon as a hard freeze comes and is sustained, pretty much all the leaves drop right then and there. Whereas almost every other tree, it's kind of a gradual, beautiful change colors and drop. So then the big contest that you guys can play is, when will the great ginkgo drop occur in your area? Well, the Midwestern Regional Climate Center developed a tool last year that looks at the climatology of various dates of when the first freeze temperatures happen. Now, we provide it certainly for like the 28 and 32 degrees, but there's multiple temperatures there. If you want to look at our site, and I do have it in the chat, I can share so that you guys can put it on the YouTube channel. You can look at that and see historically what is the average date when perhaps 28 degrees is hit, or 26 degrees. What is the earliest? What is the latest? And then you can have a little game among your friends and family of when you think the great ginkgo drop will occur in your area this year.
Ooh, I think we should start a pool here on the show here. That's a great pick. In fact, I'm bookmarking that thing right now. All right, Bill Murray, your turn. Go.
Yeah, James, I'm going to take the foghorn so I can hear its dulcet tones.
Well,
and then I will spend my time talking about great guests like the one we've had tonight.
Yeah. All right.
Yeah,
there's your foghorn.
Many thanks to Jay Farlow. Rick credited him for tonight's show. Beth, we appreciate you joining us. Some really great shows also coming up in coming weeks. Next week, we're going to talk to Frank Waugh from Wichita, and a fascinating story of the El Dorado. Troy, am I saying it right? James, am I saying it right? El Dorado, Kansas tornado, which was the first one to be studied by continuous wave Doppler. And I just noticed on the Google Calendar that I have the article for Jen for Wednesday. So don't tell her that I didn't notice this till just now. So I better get working on the article. But Alan Seals, friend of the podcast, is going to join us on the 16th. He's got a retirement party coming up in January, and a new book to boot. So Alan will join us on the 16th. Henry Buhner will join us on the 23rd. And we just inserted Brian Smith, the WCM at Omaha, who just retired. Jeremy Bauer is going to join us that night too. Good friend of the podcast also. And the other big development is that Greg Carbon is slotted in for the 21st. He may take 2 shows, James, but I'm putting that on that vacation show that Thursday night. So just in case we need to run to midnight or something.
Okay, we can just run all night. That doesn't matter. Hey, so Beth, is there anything else you need to promote before we wrap it up here? Any websites or any social media accounts? Plug away, go.
I would certainly promote our Midwestern Regional Climate Center website. So it's MRCC for Midwestern Regional Climate Center.purdue.edu. And from there, you can download historical data. You can look at rankings. If you're curious if a recent event or past event was a record for that location, thresholds, maps, and then a lot of these tools that I've been talking about today. So, and this one in any real regional climate center, that's what we specialize in. But for ours, we focus on the Midwest states.
Awesome. Well, thanks a lot for being on the show. It's been a great show this week. Had a lot of fun. And if you would like to get in touch with us and ask a question or make a comment, the email address here, it is email@weatherbrains.com. And Jen will be back next week. We'll have a long email segment. And if you're new here, we are typically on the air every Monday night. You can watch live on the WeatherBrains YouTube channel, youtube.com/WeatherBrains at 8 o'clock Eastern, 7 o'clock Central. But most of you listen, and we know that, and we're glad you consume this however you do, watch or listen. So we got to wrap this one up on behalf of the entire WeatherBrains crew. I'm James Spann. Thanks for listening. Have a great week, and God bless.
Bye, everybody.
Thanks, everybody.
Thank you,
Great
Beth.
show.
Thanks, Beth.
Great show.
Oh, thank you.
Thank you.
Great show.
We stopped
Absolutely.
being silly and did real work here for